A reading list for a humanities course consists of 10 books, of which 4 are biographies and the rest are novels, so 6 are novels. Each student is required to read a selection of 4 books from the list, including 2 or more biographies. How many selections of books satisfy the requirements? Well, we'll first probably have to think about how option 1 is to read 2 bios and 2 novels. That would be reasonable. Another option you have is the one where you read 3 bios and 1 novel. And if you're that guy or girl in class, you're really smart, and you want to read 4 bios instead of The Hobbit or whatever. So 4 bios and 0 novels. You've got 3 different possibilities, but that's not the answer, obviously. Within each of these categories, within each of these possibilities, is a new arrangement, is a possible arrangement. So, I mean, out of the 4 biographies, which ones do you pick, and how do you combine those with the 2 novels? That's what makes this a combinatorics problem. So I want to take a moment in this video to sort of go through some of the categories, well, 2 categories, and 2 subcategories in each of combinatorics problems, combinatorics situations. Each one has a formula, so once we lay those out, we're going to pick them and we're going to apply them to each of the situations and add all the possibilities together. So when we lay out the possibilities, we first got to ask the question, does the order of objects or entries or numbers, in this case books, matters? Okay, so there's this one situation, this one school of thought where the order matters. Right? And when the order matters, the problem is called a permutation. Permutation problem. Good example of something where the order matters is a combination lock, right? So only one sequence of numbers will open the lock. If the combo is 5 through 9, then 9 through 5 will not work, etc. I think it's fair to say that the game of bingo works on that principle too, but I don't really remember. And then there's the situation where the order doesn't matter. Where different, orderings of entries doesn't change we're not going to count different orders twice, okay? The combo 5 3 6 is actually the same as 6 3 5 in a numerical sense. So there's a fact where it doesn't matter, and that falls broadly into the category of being a combination. All right, lottery numbers, I think. Lottery games are examples of combination problems because you can have the winning numbers in just about any orders and still win. So after identifying these 2 broad categories, you have to open up to the subcategories, okay, in each, which depend on another question, and that question is repetition allowed, right? So are we going to allow repetition? For instance, combination locks will allow repetition because you can have the same number showing up twice. You don't use up the entries as they work. So there's permutations with repetition, and there's permutations without repetition. And then under combinations, and I'll give myself a little couple inches here. And then under combinations, you have the same 2 subcategories. The ones where repetition is allowed. You can see the same entries twice, or consider the same things. And then there's no repetition. So if you can figure out what your problem is, into which of these 4 categories your problem falls, you can apply each of the formulas. And those formulas I'm going to cause to appear right now. Okay, so those are your 4 big old combinatorics formulas, and now the work really is identifying which one we've got. Actually, before we do that, let's talk just a little bit more about these formulas. You can see there are really 3 principal symbols, okay? So the first one to talk about is n, which is defined as the number of things to choose from, okay? For instance, in our example with the novels and the bios, there's 4 bios to choose from, so n equals 4, and for the novels there's 6. So the number of things to choose from and then there's another one that appears here. There's R, which is the number of things we're actually going to pick. For instance, there are a number of situations in this problem. In one situation, we're going to pick 2 out of 4. So in that situation, we're going to consider R will be equal to 2. So there's n, the number of things you choose from, and R, the number of things we pick out of those things to choose from. And if you're not familiar with it, okay, the factorial symbol is not a variable, okay? This is defined as the factorial function. And it's a pretty simple process. When a number appears with an exclamation point like that, all right, just so by way of examples, I want to give you, for instance, I don't know, if 4 factorial shows up. Well, that means that the number that's going in there is actually 4 times 3 times 2 times 1. That's kind of the best way for me to describe factorials. That's 4 times 3, which is 12, times 2, which is 21, times 24, times 1, which is 24. Whatever number factorial, that's how it is. You just start at that number and you count down and you put time signs in between anything. 3 factorial is 3 times 2 times 1, which is 6. As you can imagine, these numbers can get pretty big, right? So once you get up to like 10 factorial, you have to multiply 10 numbers together, so they tend to get big. So that describes how we're going to work with these. And now I'm ready to probably return to the problem itself. And I'm going to read this again. So we have 10 books in total, 4 are biographies, and the rest are novels. We're allowed to select a series of books in accordance with these 3 patterns. So each pattern we're going to have to talk about, and which of these is represented by this situation. Well, does the order in which we read a book matter within the context of a problem? Probably not, okay? It just said we're going to read a selection of 4 books. It didn't say anything about what order we're working with, so I'm not going to use any of the permutation options. So this is a combination. And the next question we have to ask is repetition allowed, okay? Can we read the same book twice? I wouldn't think so. That wouldn't be a very good class. So this is a combination, but there's no repetition allowed. So we are stuck within the rightmost entry here. This is the category. This is the formula that describes the number of possibilities we have. So let's write that down. We're going to be using n factorial over r factorial n minus r factorial. Big marker. All right. Now we have to talk about each of these situations. I said that situation 1 was where we read 2 novels and 2 bios. In each of these, we're going to have to pick 2 novels out of the 6 novels for starters, right? So underneath picking 2 novels, we're going to consider how n equals 6. We're going to plug that into this formula. 6 factorial, the number of things to choose from, divided by r, the number of novels we're actually going to pick out of that group, 2 in this case, so 2 factorial. And then there's n minus r factorial, or 6 minus 2 factorial. And this turns out to be 15. Okay, you can prove that to yourself with the arithmetic at this point. That turns out to be 15. With the 2 bios, okay, we have to talk about those 2. How do I want to do this? So it's easy. There we go. I think I'll move it down here. For the 2 bios, we have to pick from n equals 4 choices. And out of those, we have to pick 2 bios, and we have to do 4 minus 2 factorial to complete the formula. And that turns out to be the number 6. Now, You could think of it. You could think of it a few ways. There's 6 situations. Every time we pick 6 biographies, 6 ways to pick a biography. Each time we also have to make a decision on a novel. So 15, 6 times, if you will. So the total thing represented by this situation 1 is total choices 6 times 15, which is equal to 90. Now we have to consider the other 2 situations and all the possibilities that arise from them. So then there was this other one where we could pick 1 novel and we could pick 2 bios. Sorry, that's 3 bios. That would also be a total of 4 books. And what I'm going to do is run the calculation again for each of these. It's pretty much the same type of deal. And so the total choices here is going to be 6 times 4, or 24. All right, almost done. One more situation to consider. And for this one, it's the one where we picked, we picked 4 bios. Okay, we picked 4 bios. And out of a total of 4 biographies to choose from, you might think that the only way to arrange a combination of 4 is one way, and you would be correct. So the total choices here is 1. It is satisfying to see that the combinatorics formula actually does work. Choosing 4 out of 4 does work, but we could leave it logical for now. So we have 1 choice out of there. So we've laid out that we have 90 in this situation, 24 in this situation, and 1 in this situation. So across the 3 situations, we have a total of 1 plus 24 plus 90 equal to 115 total possibilities.